Hey there, this is Seth Schaefer from Team Just Cause Robotics.
Alright, so what we have here is two servos that I've done a continuous servo mod to in Minimulture. So I can show you here. I can drive it around just fine like a normal robot, basically. I have some proportional speed control, though not a ton. You can go forward, backward, left, right, etc. So this video is going to focus on how exactly I accomplished this by modifying standard servos. This stick is controlling both servos just like it was when I was driving Minimulture around. When I push up on the stick, both are given the same command, and when I push down, both are given the same command. So you can see the continuous modded servo rotates continuously, but it doesn't have any positional control, whereas the regular servo, it just goes to a fixed angle and stays there. In the center position, both are off. Forwards, backwards. So you can see this is rotating one direction, and then the other direction. And I actually do have a little bit of proportional speed control, it's just not over the full range of the stick. So basically for drive, this is what we need, but we're starting with this. This is how they come from the factory. To accomplish this, basically you need to trade off any positional feedback for speed control by pretty much turning the servo controller board inside here into a speed controller. The way that these work, and I'll link a much better video made by somebody else that explains this in extreme detail, but the way that this works very, very shortly is that there is something known as a potentiometer, which is essentially a variable resistor in one of these. And a potentiometer rotates a shaft along a arc-shaped track that has a set resistance for how far along the track it is. So basically, at this position, it could be 0 ohms. At this position, it could be 5,000 ohms. And at the center, it could be 2,500 ohms. And via that, it's able to tell exactly what angle it's at. So what we do is basically, we physically disconnect this output gear from the potentiometer. And then we add two resistors that basically fool it into thinking on the right side is 2,500 ohms and on the left side is 2,500 ohms, or really anything as long as the two resistor values are equal. And that way, this will always think, the board will always think it's in the center. And then we just remove the mechanical limit from this being able to rotate 360 degrees, and all of a sudden, this is what you get. So to start out, you're gonna need a few tools. I have with me an entire iFixit toolkit that has a bunch of weird things, but you can approximate most of that with just random household things like a butter knife and maybe a pair of tweezers or something that you probably have around. So inside my kit here, there's basically just a couple things that we need. The first is this metal implement, which you could probably replace with a relatively small butter knife or something along those lines. It's helpful to have a pair of tweezers. These are helpful because they spring closed. This will just be for holding the resistors in place while we solder. And then, of course, a small Phillips head. I've liked to use this number 1. Seems to work pretty well. That should be all that we really need. And then I have a little vise that also makes holding the servo much, much, much easier while soldering and everything. I got this off Amazon for I think like 20 bucks or whatever. You can see I've melted into it because I was soldering XT60s on here, but it doesn't matter. So, first things first, we're gonna take our regular non-modified servo, stick it in the vise. Then, with our screwdriver, take out these 4 screws. I like having a little magnet tray, seems to help a lot with not losing your screws and stuff. So now, we actually don't want to pull the back cover off just yet. First, we want to pull off the top cover to get access to the gears. So simply holding these two parts together, there's 2 part lines here and here. The sticker might be covering one or both of them, so keep in mind where the sticker is. The case should just come apart like so. Now we have access to all these gears. So there's 4 gears in here. It's not hard to put them back in the right order. All of them are actually pretty different, especially the main output. One other thing, there's actually another piece in here. There's a little brass bushing that in some of them, when I pull this off, it like stayed on here. Some of them it stays in here. Doesn't really matter, just keep it, don't lose it. Next, the potentiometer is that green disc under there. The way that it is coupled to this, you'll see as I pull these gears off. So I'm just gonna try and pull off just this first gear by holding with my thumb these down. So this part has the mechanical stop that we need to remove, this little white tab. For that, you can use a pair of flush cutters, or I've actually found it might be even easier just to use a regular knife. Just like that. Toward my vise a bit, but as long as it's nice and flush there, you should be pretty much good to go. Inside of this gear is actually a D-shaped bore, so that couples onto a flat on that brass shaft, which you should be able to see there. So that's a D-shaped brass shaft. That's actually the potentiometer shaft. So I'm gonna leave this gear here and then pull these off. I like to keep them a little bit organized so you remember which was on which shaft. So just remember, these were on the steel shaft, these are on the brass shaft. Steel, brass, brass, steel. This shaft is kind of like integrated into the motor and it shouldn't come out. This brass shaft, however, we will be able to pull out, but not from this side. This is where we need to pull off the other cover and do a little bit of surgery on the motor. So this shaft is actually the position detector, and I can prove that to you. Right now, this motor is disassembled, but I can power it up just like I had before. When I reach the center position, gear stops as I rotate it one way or the other, it reverses direction. So now, if it's centered, you can see that I have the ability to reverse this direction. We're going to physically disconnect the metal contacts that actually tell it what position it's at, and then fool it into thinking we're always in this center position. And then when we do this, we'll be able to make it spin forever in one direction or the other. Alright, so at this point, flip the motor over. We're going to want the side with the wires facing us here. I'm going to clamp it below the split line, not too hard because you don't want to crush the sensitive electronics. And then this just comes off. Alright, so now we're getting down to business. This is one of the tricky parts, okay? So in here we have a board, there's a little microprocessor, the motor, and then there's a bunch of contacts, kind of hidden by these red wires that go to the motor tabs. Be very careful not to pull these red wires off, you can't solder them back on, but it's kind of a pain. So the things that we care about for the most part are right here, this, and this. Those three contacts in that triangle shape are the contacts for the potentiometer. At this exact moment, we can't do anything with that because we still have to physically disconnect it. That's kind of a two-step process. So, first thing that you need to do is, this is where you want your metal little pry tool or a butter knife or whatever, that's as long as it's thin enough. You need to very carefully pull up the wires to start this, not hard enough that you pull the wires off. As soon as you see a little crack there, try and wedge your tool in there, and then use the tool to pry the board up so that you don't rip the wires off the board. You should be able to pry it up pretty easily, and what you're doing is you're just hinging it by bending the metal contacts of the potentiometer, so don't go too hardcore on this, but bend it up enough that you can kind of see in there. Let's see if I can change the angle of this a bit so you can see better. So inside of here, what we have now is you can see an E-clip on the back end of that brass shaft. So that's the very same shaft that I was just turning with my pliers earlier. So what we need to do now is get that E-clip off, and then you'll be able to pull the whole shaft out. So the E-clip is off now. It's extremely hard to put back on, I'll be honest, but I have assembled two of these motors without getting it back on, and didn't have a problem with them running without it, because the top of the motor with that little bushing kind of keeps the shaft constrained anyway. It's probably helpful to keep this on though. So I'm going to put this back in my magnet tray, just so I don't lose it. So now you can see the shaft just completely fell out, and attached to it is this blue board. So here, this component is literally just the potentiometer's shaft, a blue plastic bushing that's actually not physically attached other than being pressed in. What matters is that in here if you look closely from the other side, you'll see exactly what this is doing. If we flip this over, that blue plastic was covering this. So, what you see here is that conductive trace I was talking about in the potentiometer. So that black area right there is a variable resistive path. The 3 contacts for this potentiometer connect to here, here, and the center one is to this ring right here. If you look closely, you'll notice there isn't actually any metal connecting the middle ring to the outside black area. That is what this piece is doing. If you see here, there are 2 little tines that stick out from this blue plastic piece, 2 metal tines that stick out. They're spaced perfectly so that one of them traces a path along the inner ring, and one of them traces a path along the outer ring. So all that this is doing is making an electrical connection between the black area and that little silver or gold ring in the middle. That is telling it what angle it's at based on the difference in resistance between the right half and the left half of whatever's beyond this little metal point. So for our purposes, we want to fool it so thinking we're in the center. So we are actually just going to pry this off, and you will destroy this thing in the process. Don't worry, we won't need it. So there's these little metal pegs that it's kind of, or plastic pegs it's kind of pressed onto. I'm just going to pry in between those pegs until I get this off. There we go. That can be tossed aside. We won't be needing it anymore. So now all we have is a plastic piece, and all you need to do is put it right back in here. And it should be able to seat itself down like that, and then it can spin freely because there's nothing stopping it, just like before. So now, if you are extremely dexterous, you can attempt to get the E-clip back on, but it's not really necessary. As long as you don't lose that blue and brass piece, you'll be fine. So, now for the board. If we bend, I'm gonna actually put the motor's top half back together so that we don't lose any of that stuff. It won't be held on with screws or anything, but it will be together at least. So we start out with the first gear of the steel shaft, which should be the shorter one. Then the first gear of the brass shaft. Whoops, I did that backwards, didn't I? Yeah, you can see there's a larger bore on the brass shaft. So steel shaft, brass shaft, shorter of these. There's a shorter and a taller brass gear. Then that goes here, the tallest brass gear, and then the main output. You need to align it with that flat on the D shaft. So it might be a little tricky because now the gears are trying to interlock at the same time that you're trying to turn this to whatever arbitrary angle that that's at now. But if you just look carefully at where the D position is, you can line it up more or less. This isn't like super rigid, so you can like angularly adjust it by maybe a tooth or two. It might not feel like it's going on, but if you give it a little force, it'll go on. So now this whole thing can pull out still. So I'm just gonna put the top half on for now. If you want a little more security, it's just kind of pushed on. You could like add a piece of tape or whatever, but I'm just gonna keep the whole thing together in the vise now. So with the vise holding this firmly but not too tight, this will not come apart anymore. We have the shaft in place and everything. This is the moment at which you could attempt to put the E-clip back on, but I'm not gonna worry about it for now. So now we bend the board back flat. Don't push it super hard or try and stab any of the components. You just want it to kind of fit into the case again. And then move these wires out of your way so you can get better access to the 3 contacts I pointed out earlier for the potentiometer. I know this sounds like it's taking forever, but honestly, doing this once you actually know what you're doing literally takes. So now is the tricky part of this whole thing, where you need a soldering iron and a little bit of patience and a little bit of skill with your iron, to be completely honest. This isn't going to be the easiest solder job. If you're brand new to soldering, this might be quite difficult. So basically, from now on, All that we need are
minutes.
tweezers and a soldering iron. So my iron, I have the TS100. I have it set to 650 Fahrenheit. Anything 600 or higher should be fine. If you don't have a temperature adjustable iron, that's fine. If you don't have a fine tip, however, good luck doing this, because that's going to be a problem. What we need now are some standard 1/4 watt resistors. Really any small resistors that are the same value will be fine as long as they're more than a few ohms. Basically, I've seen people attempt to do this with just a wire between these contacts and these contacts, and that doesn't work at all from my experience, because basically you need an equal resistance on both sides, and that resistance needs to be like significant compared to like just a wire that's like less than 1/10 of an ohm. So even just like a 10 ohm resistor would probably be fine, but I would go with like a 1000, 4.7K, something like that. I have here, I think just 220 ohms or something. It doesn't really matter as long as they are, these might even just be, yeah, I think these are 220, but I haven't checked the color codes. I don't really care. As long as they're equal values, it shouldn't matter. So the easiest way I found to do this is doing it one at a time. So you take a resistor, bend the leads down, and then leave maybe 1/4 inch, bend it back up, kind of fold it. Then do the same on the other side. Now it helps to grab with some tweezers like this that are spring-loaded. If you do not have tweezers that are spring-loaded, a nice trick is if you have normal pliers like this, you just need something that gently holds the resistor so it's not getting in the way of what you're doing. Then we're going to tin the resistor. Doing this like in the open air is going to be quite difficult so that I can get it on camera, but now, like I said before, all we need to do is get this resistor to bridge two metal contacts. So I'm bending the leads a bit closer together about the spacing between those contacts, and try and get these so that they're spaced out a little better if you can. At this point, I'm going to rotate a bit. I'm also going to take my flush cutters so I can figure out where the heck I put them, and I'm going to cut off the excess because we don't need that, and it'll just get in the way. Oh geez. There we go. Come on. It'd be hilarious if I like destroy this while I'm doing it on camera. Okay, there we go. I don't know if you can see that, but those are now very joined. Very carefully, I'm gonna bend this back a little bit just so I can see the other contacts. How long those leads were, it doesn't really matter as long as you can, in fact, still close the case after you're done. Alright, so where the hell did I put the second resistor now? Pretty sure this is it. Yeah, 2 red stripes on the... I'll probably put a little tab on text on the screen. BB, Roy, GBIV, GW, you know. So again, take the resistor, maybe a 1/4 inch, bend the leads back. Might even help to use pliers and just get it nice and tight on there. I'm gonna hold them in the springy clips again for the moment, just to tin it. And I'll go back to the regular pliers, because honestly that worked way better, even without a rubber band on them or anything. This one's gonna be even trickier, because now I have like very little access from above. So I'm gonna do the outside first, and then you can kind of, oh geez. You can kind of get the inside one, you can just solder it to the leg of the other resistor if you need to. That'll make things a little easier, I think. All right, if this actually works, that'll be impressive. But I think I did make the connections. I may have broken something else in the process, but we're gonna find out together. All right, at this point, we can check to make sure if our work was all in vain or not. Hey, it should be done. If my horrendous solder job right there can do this successfully, I assure you, yours can too. I promise that the other ones look better than this. But will it be able to turn around and stop when I want it to is the real question. This is exactly what we want. So yeah, that worked. Believe it or not, that was the sketchiest thing I've ever done, but it still worked. So trust me, you can do this too. It's not that hard. It takes a little bit of patience and a little finesse, maybe some practice soldering, but you can do it. Doesn't matter if it looks pretty, it'll still work. Now, because, whoops, I just turned that off so it's fail-safing now. Because my solder job is particularly horrendous on the inside of here, and also because it's probably a good idea in general, before I put the back of this on, I'm probably just gonna coat that in some hot glue. Okay, I haven't given this a ton of time to heat up, but fuck it. So, little generous coats of hot glue in there, assuming we never need to take this apart again. And then the cover, rear cover, there's a slot for the wires on this side. Make sure the motor wires are in there. Oh god. Now we can assemble the whole case again. Hooray! And we are done. Alright, last thing I'm gonna do, slap a label on here so that I know that this one has been converted already, and I don't confuse it with one that hasn't. I've already done, this is the fourth one, so I have one more that I can do quickly without trying to do it so that the camera can actually see what I'm doing to prove that I'm not completely incompetent. So hopefully you will shortly see a time lapse of me doing that. There we have it. One more freshly converted servo. That I went and plugged it into a drive channel. I need to make sure to have it, you know, arm and everything, but may need to trim out the center a little bit like that, but otherwise you're pretty much good to go. Okay, now for me to do the last one and hopefully time lapse it. I wasn't even really rushing that. 10 minutes, 30 seconds. All right, I just did this in 10 minutes and 31 seconds. But does it work? What the F? Oh, mechanical stop I may have not cut quite flush enough, but it just worked itself out. That's an easy fix. Okay. It was struggling a little bit just to get over the little plastic hump, so I'll show you how to fix that in case that happens to you. Okay, so to fix it catching mechanically, pull off that first gear,
Just make sure that you've cut that plastic nub as flush as possible. You could even file it back if you want to be extra safe. Yeah, I can still see a little nub there. Yeah, if you just look at it like dead on the side, you don't see a nub sticking out, then you're good. That was the problem. I could see a little bit of a nub sticking out. And now just pop it on. Put the case back together, if I can find where I put the top half of it. Perfect. And there we have it.
I know things have gotten pretty crazy in the US recently due to coronavirus. I'm fortunate to be in a position where I'm not at risk of losing my job and I'm capable of working from home. I know many others aren't so lucky, so recently in an effort to help, I donated to the No Kid Hungry organization, which helps feed school children in low-income areas who are now without school lunches. The city is currently matching donations, so I encourage others who have the financial means to donate as well. Make sure to like and subscribe for more content. I'll have more videos in this series in the next few weeks. Thanks for watching!